Hi, my name is Bara, and the fluid phenomena that I'd like to demonstrate today is known as the rope coiling effect, and it is best seen with viscous fluids such as honey. The variables that affect the rope coiling effect include the fluid density, the surface tension, of course the kinematic viscosity, and the height of the rope coil. And depending on how the variables change with each other, they could also introduce 4 different types of rope coiling effects as I shall now demonstrate right now.
So as you can see, the setup is pretty simple. There is a jar of honey and a paint stick which is used to dip into the honey. But before I get into the actual experiment, there are a few variables that must be noted apart from the variables and properties that I've mentioned before. We have the coil height and the tail height which come together to form the total height h. We have the radius at the top, which is known as a sub 0, and the radius at the bottom, a sub 1. And more importantly, we have the angular frequency, omega. The first flow is known as the viscous flow regime, and this is where the total height h is relatively small, so the fluid would form a spiral as it naturally has to get out of the way of itself. The second condition is known as the gravitational regime, and this is where as h increases, gravity starts to come into play and the coiling becomes more stable and uniform. The third type is known as the inertial regime, and this is as h becomes very large, the radius becomes very small, and as a result there is a much higher frequency. Somewhere between our gravitational regime and the inertial regime, there suddenly forms an unsteady flow from what was once a steady flow. This is known as the inertial gravitational regime. However, by increasing the height again, we could form a steady state flow again. Fluid dynamics is awesome.